Okay, so a charged pion hits a proton with energy E, and the proton is at rest and it produces a proton, antiproton, and a neutron. We need to calculate the minimum energy the pion had for this to occur. I'm going to start out by writing the full momentum vectors of the pion and the proton. So we said the energy is E, and it hits it with the momentum of p pi. And since the proton is at rest, we can just take the energy to be m proton. It's just its mass. Momentum is 0. So we're going to use the Mandelstam variable S, which is Lorentz invariant in all frames. Okay, so let's do that here. We get p pi plus. When we square this, we get p pi squared p proton squared plus 2 of the energies, which is just E and the mass of the proton, minus the momentum, and the momentum of that was 0, which just cancels. So we're left with this. Recall from relativity that for momentum vector of is just equal to the energy squared minus the momentum vector squared, which is also, sorry, that's defined as, which is also equal to the mass squared. So we can replace these terms, and S is going to be equal to the mass of the pi minus mass of the proton squared plus 2e mass of proton. Right. Now, this is from a lab frame. We're going to do it from, the final product is going to be taken from a center of mass frame. This is to calculate the minimum threshold energy. So let's start by writing the momentum vector, which is, let's just call that P final. It's going to be, we said, a proton, antiproton, neutron. We can just all combine them because they're not moving. 2mp, because proton, antiproton have the same mass. And momentum 0. Cool. Repeat from before. S is just going to be equal to 2mp plus m squared minus 0 squared for the... Right. I mentioned before that the Mandelstam variable is invariant, is Lorentz invariant in all reference frames. So we can equate these two, and we will get m pi squared plus m proton squared, the energy that we're trying to find, equal to mass proton, mass neutron, squared. So we just do simple rearranging. It's going to be equal to that's the answer. You can just factor in the actual values to solve it, but this is the bulk of it done.